Greetings, this is lesson 2, not practice problem, YT14, Charlie and the Chocolate Factory Cost, Revenue, and Profit. So we're asked to find out a few things about Charlie's chocolate shop. During the week before Valentine's Day, Charlie advertises that his chocolates will sell for $1.80 a piece instead of $2 each. Fixed cost for the chocolate shop is $450 a week, and he estimates that the total cost about 60 cents to produce. Charlie estimates that he can produce 3,000 chocolates in 1 week. Okay, so write a function for C of n, which is the total cost for a week that if he makes n chocolates. Well, notice that the 450 here, that's fixed. He has no control over that. Whether he makes a single chocolate or not, he's got to pay $450 to, pay his rent, lights, etc. So that tells you that the cost with respect to n is going to be $450 as a fixed cost, plus it's costing him about 60 cents per chocolate to produce. So you got to put that in there too. So that's the 0.60 times n, or 0.6n. Okay. Now his revenue, that's how much money he's bringing in. Well, during this particular time of the year, Charlie is selling at a discount of $1.80 each. So that tells you that his revenue function, R of n, is going to be equal to 1.8 times n, or $1.80 n. Okay. Now we need to go write a profit function. Okay, so you got to remember that profit with respect to n is going to be equal to what? Well, your profit is equal to your revenue less your costs. So it's how much money you bring in less how much money you spent. And so that's your total profit. So to get that, let's come over here. I was going to take a little bit of room. So that's R of n minus C of n. So our R of n is 1.8n minus our C of n, which is $450 plus 60 cents per chocolate. And so that, by the way, that's our P of n. I should have written that down also. So that's my P of n there. Okay, so that's going to be 1.8n minus 450. You got to distribute that negative. Don't forget that. Minus 0.6n. So that's taking or considering that being a negative 1 out front and distributing it over those parentheses. Okay, so that gets me 1.8n, and then subtract from that 0.6n, and then subtract from that 450. We'll take that step just to put the n's next to each other, collect up our like terms, and we're going to get what? Let's see, that's going to be 1.2n, right? And then minus 450. So in other words, I earn $1.20 on every chocolate that I sell. Hopefully that makes sense there. Okay, so that's my profit with respect to n. So 1.08 minus 0.6 gets me back $1.20. All right, cool beans. So now interpret the meaning of P of 300 is equal to negative 90. So let's go get the calculator right out real quick here. If I can get that going, there we go. Let's go check and see. Let's make sure we actually get negative 90. That's a good way to error check our function and make sure that we actually got the right function going here, okay? So they want us to tell them what is P of 300 and then interpret it. So let's see, P of 300 would be 1.2 times 300 minus 450. So if I do that, get back negative 90. Oh, I was saying 900, but it was 90. It is late. Okay, get back negative 90. Whew, good. All right, I'm happy. I got the right number. That's the main thing. Even if I was saying it wrong. So that says is that if he only makes he only sells 300 chocolates, his profit's going to be negative $90. He better sell more than 300 chocolates or he goes into the hole. It's a loss. Okay, he gets to eat his chocolate. All right. So that means he lost $90. Okay, determine the practical domain and the practical range for P of n. Use these in the information to define an appropriate viewing window for your graph of P of n. Sketch the graph from your calculator in the space provided below. Okay, practical domain is the number of chocolates that Charlie can make. So Charlie estimates that he can make 3,000 chocolates in 1 week. So we're just talking about this particular week. See, it's the Valentine's week that it's $1.80. So this function only corresponds to Valentine's, okay? And his 450 is his weekly cost. So everything here is for the week, our domain, the whole 9 yards. So the practical domain is going to be, well, he can go from where? He can make no chocolates, which bad idea, but he can do that. And then he can go up to, well, he estimates he can make 3,000 chocolates in a week. So that's his practical domain, okay? Well, what about the practical range? Well, to figure out the practical range, you're going to have to go back and consult our profit function here. I'm just going to come back to this, and we're going to take the endpoints from our domain. We'll plug those into our function, and that'll give us back the endpoints for the range. So if we do that, we put in a 0 in here. In other words, if we say the lower endpoint of our domain is, or excuse me, our range is going to be p of 0, and the upper endpoint of our range is going to be p of 3,000. By the way, the only reason we can get away with this is because we're using a linear model here. If this was a nonlinear model, then I can't necessarily do what I'm doing here, okay? But with linear models, this always works, all right? So p of 0, that's going to give me back negative 450. That's my lower endpoint. And let's go see what the upper endpoint would be. So that's going to be 1.2 times 3,000 minus 450. So his maximum profit he can make that week is $3,150. So if he doesn't sell any chocolates, that makes sense. He loses 450. If he sells every chocolate he makes of the 3,000, excuse me, then he will make $3,150. All right, so they want us to go in and put this in the calculator. So let's do that. So let's hit the y equals, clear out our y1 here. We'll put in 1.2 x minus 450. And now we're going to use those really cool domain and range numbers to set our window here. So our lower number is going to be at 0. Our upper number is going to be at 3,000. Let's make our x scale equal to, I don't know, let's make it 1,000. I don't know, how about 100? Wow, I'll tell you what, let's make it 500. That sounds good. And then our y min is going to be negative 450. And our y max is going to be 3,150. Now we'll make our y scale 500 again. Let's see if that works on the scaler. I think that should be good. Okay, press graph. And there you go. All right, so that's the graph over the practical domain. Notice that this part of the graph down here, we lost money. This part of the graph up here, we make money. So when we're below the n-axis, we lose money. When we're above the n-axis, we make money. When we hit the n-axis, that's the break-even point right there. That's where we either lost money or made money. Okay, so now what we're supposed to do is make a reasonable sketch of that on a graph, and then we're going to mark that break-even point that we were just talking about. So come over here and make a reasonable sketch. Let's get a different color here for the axes. So that's our vertical axis, that's a horizontal axis, and then our graph looks not quite unlike, but similar to that. Okay. All right, and I say, how many chocolates does Charlie make to break even? Show complete work when you do this, and they want us to mark that break even point right here on the graph. Okay, so remember this is n by p of n. Okay, so how do we find the break even point? Well, the break even point, the way you do that is that means that p of n is equal to 0. In other words, your profit is 0. So solving the resulting equation, 0 is equal to 1.2n minus 450 will give me how many chocolates I have to make so that I neither lost money or made money. So let's add 450 to both sides. And let's divide both sides by 1.2. Okay, move my calculator out of the way of my work there. Here we go. And so that's going to say, take 450, divide that by 1.2. And we need to make 375 chocolates. So if we make 375 chocolates, we will break even. So notice that the ordered pair there is 375 by 0 for 0 profit. Okay, that's that ordered pair right there. Okay, hopefully that helps. Give me some feedback if that was good or not. I'll do more if I need to.